Hello. So in today's video we're gonna do the mechanism for glycoside formation. The first thing you want to do is make sure that you're going from a molecule that is electron rich to a molecule that is it lacks electrons. For example, this carbonyl right here is partially positive, so that's the carbonyl you want to attack. So you will go from the oxygen, because he has lone pairs, he's electron rich, to that partially positive carbonyl. And this is how you would draw the curved arrow. You want to make sure that you always go from electron rich to electron poor, not the other way around. For example, I went ahead and wrote it. This right here, this is wrong. You don't want to do that. And for the second rule, you have to make sure that you write the arrows correctly. As in, this is an equilibrium. This is one way. Just make sure that you know how to use these and you apply them. So here I have the reactant, the reagents and the products. And as you can see, here I have, this is beta D glucose, and we're gonna treat it with hydrochloric acid and an alcohol. As you can see, the products are gonna be both. It's gonna be beta D glucopyranoside and alpha D glucopyranoside as well. Before going ahead and start the actual mechanism, first I want to make sure that you guys understand that the only changes among these three structures here, doesn't look good. These structures is the fact that these right here is not there anymore. So these ether, this OCH2CH3 replaces the OH. To do that, you have to convert this OH in a better living group, because OH by itself is not a good living group. I hope you can remember that. To do that, we're going to use this H right here from hydrochloric acid. This is gonna go here, and this is gonna leave, because chloride is a good living group. Yeah, that's what I wanted to make sure you guys understand beforehand. Another thing I would like for you guys to know is that the naming here, this is called alpha because this is axial and pointing down, and this is up here. And this is called beta because this is pointing up right here, and this one's up as well. So just keep that in mind. Depending on the position that this is right here, it's gonna determine if it's either beta or alpha. So just keep that in mind whenever you're doing these structures. Just remember that the whole purpose of this reaction is to go from the sugar to an acetal right here. So just keep that in mind as well. Okay, here on top you can see the overall reaction. I wrote it down for us to guide ourselves while doing the mechanism. Okay, just remember that the only changes in the structure is gonna be this. gonna be the OH here is gonna be replaced by OCH2CH3. That's gonna be the major change in structure. There's nothing else. There's nothing new. It should be pretty simple to do. Okay, so the first step is to convert this oxygen, this OH right here, into a good leaving group, so it can leave and this can attach to this. This can attach right here instead of the OH. And that's how you get this. In order for that to happen, these lone pairs, they have to grab this hydrogen and chloride has to leave. So let's see how that looks. Okay, so as you can see now, this is how it would look. This is positive right here, because it only has 1, 2, 3, 4, 5 electrons around oxygen. Oxygen needs 6 to be full and to be stable. So that's why it has a positive charge. Now that oxygen has a positive charge here, this is now a good leaving group. So the next step would be for this to live, but this carbon right here is not gonna let this leave, because then this positive charge is gonna be on that carbon. A positive charge is gonna be right here, and that's not good. So we need to somehow make this leave and have the molecule stable at the same time. How can we do that? Well, we have electrons here on the oxygen adjacent to the anomeric carbon that has the OH2 positive. So one of these electron one of these lone pairs is gonna make a double bond here, and it's gonna cause this to leave. And when this leaves, this is gonna leave us H2O. So right after that water leaves, it's gonna form this intermediate. And since this O right here made a double bond with one of its lone pairs, it's now charged positive here. This intermediate is called oxocarbenium. A double bond oxygen with a positive charge, it's called oxocarbenium. Okay, so now we're gonna make use of this alcohol. We have to somehow put it right here in this OCH2CH3. So to do that, remember that this oxygen right here, it's positive right now. It has 1, 2, 3, 4, 5 electrons. It's missing 1, so it's positive. It has a charge of positive. Now, to make this oxygen neutral, this lone pair has to attack this partially positive carbon, and then this pi bond, the electrons in the pi bond, is gonna go to oxygen, and it's gonna make oxygen neutral again. So let's see that. We're almost done. There's one last step, and because this oxygen right here, it's lacking electrons, you can see 1, 2, 3, 4, 5. It's positive. And this hydrogen right here, it's very acidic. So we have to get rid of this hydrogen with a base, so this oxygen can go back to neutral and be stable. To do this, to remove this hydrogen, we're gonna use a base, and we still have chlorine ions in the reaction. So we're gonna use this to grab the H. One of its lone pairs is gonna grab the H, and the electrons are gonna go back to oxygen, resulting in a neutral molecule again. So this will be our final result. This right here. I just realized this right here, it looks like CH2OI. It's not an I, it's an H. It might have been deleted accidentally. But yeah. So when this Cl minus grabs H, it forms HCl. And it's gonna be a byproduct. Okay, so here we have from the intermediate here to the product being up and to the product being down. I just realized I should have written this right here in the other way so you guys wouldn't get confused. But yeah, let's do it now. So instead of the purple color, so it's up. The red color is gonna represent the alcohol going down. Okay? So we have this here. The product for the up, for the alcohol attacking up, well, part of the product is gonna be this. This H right here is gonna be taken by the Cl minus. But I haven't showed that step yet. How it's gonna look. Well, it's basically gonna look like this one right here. All right. So we have here up and down. Up and down. All right, so let's see what would be the final two products. Is beta, D, glucopyrinoside, and it's beta because it's going up here. And the one on the side is, oh, I don't have space here. Okay, let's see. This one is alpha D glucopyrinoside because it's going down. So these two right here are our final products. And that's it for the whole mechanism. Hope you guys understood it and didn't have any problems. Thank you.